Welcome to mixing with constant volume. So in this example, an 800-gallon tank is currently full of salt water containing 80 pounds of salt. Saltwater solution containing 1/4 pound of salt per gallon is being added to the tank at a rate of 2 gallons per minute. At the same time, the tank is draining at a rate of 2 gallons per minute. Our first step is to write an IVP modeling the pounds of salt in the tank. So just some key things to keep in mind here. We have an 800-gallon tank, which is full. And that 800-gallon tank is starting off with 80 pounds of salt. So what we have is that our quantity at time 0 is 80 pounds. We are pouring water in at 2 gallons per minute. And we are pouring water out at 2 gallons per minute. Since these match, the volume of the tank should remain constant at 800 gallons. So since we're adding and draining at 2 gallons per minute, the volume remains constant at 800 gallons. Now, the solution that we're adding has 1/4 pound of salt per gallon. So the solution that we're adding has 1/4 pound per gallon. The solution that we're losing, we have however many pounds are in the tank per 800 gallons, right? So each gallon should have that overall quantity divided by the 800 gallons. Here we're assuming that the salt is essentially immediately disperses throughout this tank, and that we keep that the whole tank has the same concentration. So it's possible that that doesn't happen here. We're simplifying things, assuming that the tank, the salt immediately disperses, so the concentration is even throughout those 800 gallons. So from here, then, we can go ahead and set up our IVP. So we have Q prime is rate in minus rate out. Our rate in, we were looking at 1/4 pound per gallon times 2 gallons per minute. Our rate out, we were looking at Q over 800 pounds per gallon times 2 gallons per minute. So this leaves us with 1/2. So Q prime is equal to 1/2 minus Q over 400 And again, our initial condition was that Q of 0 was equal to 80. So this here is our IVP. Once we have our setup, the next stage is simply to solve the IVP. So when we go about solving the IVP, we have, again, Q prime is equal to 1/2 minus Q over 400 with Q of 0 equaling 80. We can rearrange our differential equation. So it's in the format Q prime plus 1/400 times Q is equal to 1/2. We find the homogeneous solution. We have Q1 is equal to e to the negative integral of 1/400 dt, or Q1 is equal to e to the negative 1/400 t. From here, we do our variation of parameters. We set Q to be some function u of t times Q1. And we get, therefore, that u prime is equal to the right-hand side, 1/2 divided by Q1. Or in other words, u prime is equal to 1/2 e to the positive 1/400 t. I need to give myself a little more space. From here, if we integrate, we get u of t is equal to 1/2 times 400 e to the 1/400 t plus c. We would divide by 1/400, that's equivalent to multiplying by 400. So we have u of t is 200 e to the 1/400 t plus c. We therefore get from here that Q of t is equal to, our Q1 was e to the negative 1/400 t. So e to the negative 1/400 t times 200 e to the 1/400 t plus c. And this becomes 200 plus c e to the negative 1/400 t. At this point, then we have our initial condition. So this is our general solution. So now we'll go ahead and use the fact that Q of 0 equals 80. And we get 80 as equal to 200 plus c times e to the 0th. And that leaves us with c as equal to negative 120. So we wind up then with Q of t is equal to 200 minus 120 e to the negative 1 over 400 t. So then we want to know, as time goes to infinity, how many pounds of salt will be in the tank, or how many pounds of salt will the quantity approach. So we'll look at the limit as t goes to infinity of q of t, or the limit as t goes to infinity of 200 minus 120 e to the negative 1 over 400 times t. That first component just goes to 200. The e to the negative 1 over 400 t approaches 0. So this goes to minus 0. And we just get 200. So as time goes to infinity, the quantity of salt in the tank approaches 200 pounds. So as time passes, the quantity of salt in the tank approaches 200 pounds. And if the quantity of salt is approaching 200 pounds, that means that the concentration approaches 200 pounds per 800 gallons, or 1/4 pound per gallon. And that was precisely the concentration of our second solution. So that is solving a mixing problem when we have constant volume.